All right, so far progression has gone as follows. Parabolas where only one variable squared. It's either x equals y squared or y equals x squared. We've talked about circles where both variables are squared. And because it's the same distance, we can just use a radius. We've talked about ellipses where both variables are squared, but it's different distances because both of those x squared and y squared have different numbers attached to them or under them. And in the end, that equals 1, not r. The question from circles to ellipses was what if we're going different distances? But the question for today's graph, which is called the hyperbola, is what if one of the squared variables is negative? This question will be answered when we graph, but the key idea is that if you understand how to graph an ellipse, then you pretty much know how to graph a hyperbola. And that's why I don't really have even a picture or anything to work with. Outside of that, I'm going to set this up and show you and let that go. Let's just imagine for a second that this is a ellipse, because let's imagine that is actually a plus y squared. The center would be at 0, 0. The x's would go 5, 1, 2, 3, 4, 5. The y's are 1, 2, 3, 4, 5. The y's would go 3, 1, 2, 3. I don't know why I put all those dots, but anyway, that would be our start if this was an ellipse. But the problem with the ellipse versus a circle or a hyperbola, let's just imagine that your teacher is really good at bending paper clips to make perfect circles, but let's just imagine that's a circle, is that if y is negative, then it cuts along the y-axis and it flips these pieces around, making it into a hyperbola going this way. And then in the other case, again, let me get this back here, if x was negative, then that means that in this circle, or whatever it would be, it cuts it across this way and turns it to go that way. So again, that would be a x-axis cut if x was negative. This would be a y-axis cut if y was negative. And that's the only thing you need to remember about it. The question is, how do we do it? And even that is easy. Once you have your points for the ellipse, you pretty much just make a rectangle with those. And from that rectangle, you now will connect diagonals. So diagonals meaning it goes all the way across. And the diagonals that we are creating is our asymptote. I gotta make sure I do this right, or at least mostly right. And so because we know that it is a y split, y is negative, we know it cuts this way, which means it should go that way. And that's important because if these two were flipped around and x was negative, even though the numbers were the same, if this was y squared over 9 minus x squared over 25, you would still use this setup, but it would be cut this way and it would be top and bottom. So it's important to understand if y is negative, that's your cut, which means it's going to go like this. And again, from that vertex, it's going to approach those asymptotes and be done. That's the graph you're looking for. All right. Looking at another one, once again, y squared over 4, x squared over 16. Again, your center is here. Y is 2 because, again, that is your y number. X is 4. 1, 2, 3, 4. 1, 2, 3, 4. Make your rectangles. Draw your asymptotes. And this time, again, once you get your asymptote, you ask yourself again, which one's negative? It's the x, which means it cuts along the x-axis, which means that it would go this way. And that is all that it takes to graph these. And as I told you, once you get the general concept, it's a pretty easy thing to do. Outside of that, there's nothing else on those. Again, in this case, your vertex is based off of your positive variable, and the other one, it was based off of vertex and co-vertex, I believe. But outside of that, one more. In this case, x is moving to 3, so it's going to be 3, 0, because there's nothing on y. 1, 2, 3. I don't think I'm going to make it. I'm not going to make it. This is a terrible question. Probably should have put the 4 under here, but anyway. Actually, I'm going to. So with that, we go, since that is a 4, we go 2 left, 2 right, because that's with your x. We go 3 up, 1, 2, 3, and 3 down, 1, 2, 3. We make our rectangles. And our asymptotes, same as usual. Again, it doesn't need to be a perfect rectangle, but you do want to make sure your asymptote is clear more than anything else, because the rectangle just gives us the ability to see the diagonal that we would draw. And then from there, the question is, which way is it cut? It cuts along the y, which means it'll be like this. Because again, if y is negative, it's going to cut along the y-axis. It's going to open that shape up and make it turn around the other way. That's it. So, if they want the vertices of the hyperbola, in my opinion, again, the vertices would be the main points here and here, and all you have to do is recognize that your center is at 0, 0, and know that this is going to go along x plus and minus 6, which means that it would be -6, 0, and 6, 0. At least what I would think. If it doesn't work like that, let me know, but I forgot to check that before I did it. But just common sense says that if x is your value and x is positive, then it's going to be this one, because whatever is negative doesn't have a vertex because it's not even part of the graph. Find the vertices of the hyperbola again. This case, again, on purpose, we made this a little different. X is 1, y is -3. Your x is actually the positive is going to be where your vertex comes from. So this is going to go plus or minus 3 under y. So it's going to be at 1, 0, because that's what -3 is. I'm sorry, +3 is, and 1, -6, because that's where your -3 is. These would be your vertices. Based off of your center, you're moving up and down 3, and there you go. All right. And then, of course, the last thing we need to see is to write the equation in standard form. And again, looking at it, it looks kind of like an ellipse, but the difference is one of them is negative, one of them is positive. So it's the same exact thing. It's just a matter of getting used to what's going on. And again, you just want to organize yourself a little bit. And you do want to be careful when you do your factoring, because a lot of people would overlook the fact that taking out a negative does have to change that also. But anyway, 3736 equals 0. So what we're going to do is take off our -49 and have x squared should be minus, because again, we took out a negative and changed the sign. 784 divided by 49 is 16. Plus 25 times y squared plus 10y minus 3736. But here's the trick, and we saw this again on the other ones with the parabolas. If that number goes in, it's getting multiplied by a negative, which makes it a negative that I'm adding, so I need to offset that one with a positive value of it. This is still going to be positive, so we offset it with a negative, and of course equaling that to 0. And that's what I love about it, is how much work it takes just to get this thing done. So x minus 8 squared makes 64. Y plus 5 squared gives us 25. 64 times 49, 3136. 25 times 25 is 625. In the end, negative 3736 plus 3136 minus 625 is negative 1225. Which again, it would be a smart shortcut if you're going to practice these enough to just move it over, but we'll do it the standard way for now. That's why I almost put equals. Then we of course move it, so negative 49 times x minus 8 squared plus 25 times y plus 5 squared equals 1225. And of course the last thing you do is divide, because we need that to equal 1. And I'm going to write this in the real standard form, which means I know this is going to be negative, so I'll put my y first. Anyway, 1225 divided by 25, I'm assuming it's 49. There it is. So it'll be y plus 5 squared over 49 minus x minus 8 squared over 25. Again, be careful taking too many shortcuts, because you want to bring that number down, equals 1. And there you would go. So this does represent the last conic section. The rest of the chapter is going to look at blending everything together and using these equations as systems to solve. For now, let's just really quickly review the rules of general equations. Again, if it's only one squared variable, which means there's a regular x and a squared y, or a regular y and a squared x, we have a parabola. If we have both variables squared and positive, because we just learned that negative cuts it open, so both variables squared and positive with the same distance in both axes, we have a circle. The reason I have this example here is if you have the same number here, that's actually just a circle, which should be written as x squared plus y squared equals 25, because if you multiplied by 25, these would cancel, and that would turn 25, and there is your r equals 5. So even if you thought it was an ellipse, if you have the same number on the bottom, get rid of it, put it in standard form that way. And then again, if you have both variables squared and positive, but different distances, it's ellipse and both variables squared, and one is negative, then you have a hyperbola. So outside of that, go ahead and go to the homework, and good luck. I'll talk to you all later.